Welcome to Chapter 7-6, Solving by Substitution. It's one of my favorite methods for solving systems of equations, also known as simultaneous equations. If you have ever played on a seesaw, you likely know that even people who don't weigh the same amount can balance each other on a seesaw. The heavier person can simply move closer to the fulcrum, which is that middle point where the seesaw is supported. Now, brilliant people with levers have actually figured out that in order for a seesaw to be balanced, the product of the weight of one side and the distance it is from the fulcrum has to equal the product of the weight on another side times its distance from the fulcrum. In other words, this formula would represent the theory or the science that has been proven by people with levers, and that is that the weight A times the distance x on one side is equal to the weight B times the distance y on the other side. Now, let's pretend that we have a little girl who is a little bit chubby, perhaps, or maybe she's just simply older. But she weighs 40 pounds and her little brother weighs 20 pounds. Now, in order for them to balance, their distances from the fulcrum must be such that her 40 pounds times her distance is equal to his 20 pounds times the distance that he is from the fulcrum. And let me just say, these pictures are not necessarily drawn to scale. Now, let's say the children are seated 12 feet apart from each other. Okay, so we know her distance plus his distance equals a total of 12. We just don't know what her distance or his is. And that's, of course, what we're going to find out using the substitution method. Now, we have two equations, 40x equals 20y, and we also have x plus y equals 12. And there is more than one way to choose to solve this, even in choosing to use the substitution method. For instance, you could say that 20y equals 40x and solve this equation for y, which would give you 40x divided by 20, or 2x equals y. And then you could substitute that value into y. But because a lot of times when you have that situation, you don't end up with pretty numbers to deal with, I'm going to just use this equation. And I'm going to just solve it for, let me solve it for x, okay? Now, in order for me to get x by itself, I have to subtract y from both sides, okay? And so when I do that, I end up with x equals 12 minus y. Okay, simple enough. Now, the substitution method means that because x equals 12 minus y, I can go back to this other equation, and instead of using x here, I can use 12 minus y, which means that I could have 40 times 12 minus y is equal to 20y, and it's equivalent to 40x equals 20y. So, of course, now I have to figure out what 40 times 12 is, and I think it's going to end up being 480, and I hope I'm right. And we subtract the 40y, because, of course, we're distributing, and it equals now 20y. Okay, so I'm going to go ahead and move my negative 40y over to the other side. So I'll end up adding 40y to both sides, which gives me 480, sorry about the shake, is equal to 60y. And I can divide by 60, which gives me 48 divided by 6. So I can find out that y is equal to 8. Okay? Now let me see if I can find another sheet of paper here to make it life a little bit easier. Okay? So if y is equal to 8, and I know from this equation that x equals 12 minus y, I can simply substitute that value for y right there. So x equals 12 minus 8, or x equals 4. Okay, and you can see, of course, that I can plug it into the original equation. 40 times 4 is equal to 20 times 8, and both sides equal 160. So I can check my work, which means that I know for a fact that I am correct and life is good, at least for that one problem. Now your book also gives you these lovely examples where they give you line segments. So I hope you're getting used to them so far because they are kind of a nice way of doing things. Now you can see that according to this line segment, x plus these 4 y's is equal to 25. And then you can see that this x is equal to y plus 5. Okay, so if you took those two equations, you could set them up just like this. Your book is going to have little circles here, and they're going to tell you that because this x plus 5 is equal to x, you can take that value and substitute into the equation for x. So when you have line segments, that's what they're going to try to get you to do. Okay, so if you started off with x plus 4y equals 25, and you're going to substitute that y plus 5 into the x, you end up with an equation that looks like this. Y plus 5 plus 4y equals 25. If you simplify it, you end up with, you end up with 5 plus 5y equals 25. Of course, we'll subtract the 5 from both sides, and we end up with 5y is equal to 20. So y is equal to 4. Now, we can plug that in right here. Okay, so instead of y, we can put in the 4. So we know that x is equal to 4 plus 5, so x is equal to 9. Okay, and again, if we can substitute our values in there, we can check our work. Okay, so we have that x is 9 and y is 4. So I can go to this original equation and say 9 plus 4 times 4 equals 25. Well, 9 plus 16 does equal 25. So I have checked my work and I know that all is well, at least for that problem. Okay, let's try another one. They will give you some without pictures of either seesaws or without line segments. And so let's say you had this picture. Okay, I'm not picture. If you had these two equations, you can see that you have 2x plus 3y equals 8, and you have y minus x equals 11. Now the easiest way to solve this, in my opinion, is just to go ahead and solve it for y, because you can do that by simply adding x to both sides, and you can see that y is then x plus 11. Okay, so we're going to take that x plus 11 and substitute it right here. So we end up with 2x plus 3 times x plus 11 instead of that y is equal to 8. Okay, we're going to have to distribute here, so we end up with 2x plus 3x plus 33 is equal to 8. Or 5x plus 33 is equal to 8. We'll subtract 33 from both sides. Okay, and I don't know offhand what this equals, so I'm going to do 13 minus 8, which is 5. Then this ends up being 25. So 5x equals negative 25. So x equals negative 5. Okay, so I take that value, I can plug it in right here. So y equals negative 5 plus 11. So I get y equals 6. And again, because I'm a good student, I'm going to take those values, x equals negative 5 and y equals 6, and I'm going to plug those into the top equation. Okay, and I'm going to see if I get the correct answer. Negative 10 plus 8, 6, just kidding, yes, 18, can't think here this morning, equals 8, and I know that I'm correct. And that, my friends, is all I have to tell you. You now know how to solve by using substitution. I hope you like doing it, and I'm sorry that I cut off all of that bottom part.